everyone, welcome back. I hope you enjoyed your lunch. I know I did. Next up, we have Ben Shaw joining us all the way from Auckland, who is here to talk about development. Ben Shaw, everybody.
Thank you. Yeah, hi everyone. My name is Ben. I'm an amateur Python developer, and this is middle out Python development. Just some background or stuff about the talk to start with. You should have some experience with Python development. This is sort of an intermediate level talk, but hopefully even senior developers will be able to take something away from this. In all my examples, I'm using Django, but just due to the nature of what I'm talking about, this will apply to other frameworks as well. As developers, we're often told to do it fast, and that usually means that we end up doing everything at once. What do I mean by this? Well, let's say we're starting a new Django project, and our process might be something like define our models, write our views, turn on admin, build some templates, put in the test data, and then see if it all works. And it's only when we get up to this stage here that we actually start testing. What we end up with is a kludge of stuff with our HTML, controllers, datas, templates, views, and models. And then when it comes time to test, we test here, or here, or here, or somewhere here. What we really should be doing is decomposing our application into separate components, and then just test at the boundaries between them. So that's here and here. So that when it comes time to bring everything together, it all fits nicely. And at any time, we can swap out a component with another one, and we know everything's going to fit together. To demonstrate this, I'm going to need an example application. And I've decided to make a cat database, because internet. What's a cat database? Well, it stores cats in breeds. Each breed has a name, and each cat has a name and a breed. Now, if there's any solution architects in the audience, that's the UML diagram for it. And just to illustrate it a bit further, this is what it looks like. On the main menu, we can choose to look at cats or breeds. If I look at the, if I click on cats, I get a list of cats. Because there's nothing there at the moment, we just have an option to add a new one. If I go into that, I get a form for adding the cat's name and selecting its breed. And then when I save it, I see the cat in the list. And I can do the same thing with the breeds as well. So it's just a simple Django CRUD application. So I'll start off by looking at the bad way of doing it. When I say the bad way, I might also refer to this as the old way. But I just mean the traditional Django way of using everything that Django provides you. So this is the code for the view to just look at or edit a breed, and it's just basic Django stuff. We get the object, the breed, out of the ORM. We pass it through to a model form, and then save it if it's valid. And we pass that form through to render and just render the template. How would I go about testing this? Well, I'd probably mock my breed.objects.get, probably mock the breed form, probably mock render, and then just assert that all of these are being called correctly. It's a little bit tricky to mock this. Well, mocking it itself is easy, but how do I know what parameters I should be passing to get the right data out? And am I even sure that the data source is returning the right thing? Should I write a test to test the data source? Is that overkill since it's just the standard Django data store? Maybe using the standard Django ORM itself is overkill. So I have a lot of assumptions and questions, and it all sort of leads to me asking, what other implications does locking myself into the Django ORM mean? Have I committed myself to Django when something simpler would do? Have I committed myself to a database when something simpler would do? Basically, have I committed myself to blank when blank would be better? So looking back at the sort of architecture, what I want to do is start developing here. which is why I call this middle-out development. So first I'll talk about building and testing this boundary here. And this is all about providing the data to the view. So I need to just make something that provides me the data. I've got to just write this quickly for testing, but it should have a consistent interface. And it needs to just be of good enough quality to do whatever I need to do at this stage. For the first take, I'm just going to do it really simply and use a Python dictionary in memory to store the objects. So I've written a data facade class which does this. This isn't all the code, but I'll just highlight some of these important ones. Firstly, I can put a cat into here. I first set the object, the ID of the cat. I then also put the cat's breed. And then I store the cat into my storage dictionary and return its ID. The set object ID just checks if my object already has an ID, and if it doesn't, it gets the maximum ID out of the data store and adds 1 to it. So this is basically just an auto-incrementing key. Then when I want to get the cat back out, I just provide the ID and we get it out of the dictionary. And there's similar methods for getting and putting the breed and getting a list of cats or a list of breeds. So this was quick to write. It's very simple and it's in the memory, so it's fast, but unfortunately it's volatile. So every time Django restarts, we lose it. To test this, it's basically just storing stuff. So we just need to test that our storage behaves as we expect, i.e. stuff goes in and stuff comes out. The interface is whatever we've defined, and we just need to test it as appropriate. So because I know that I'm going to be writing some more data facades, the way I've decided to test this is just to build a base test class that implements all my test methods. This is just an example of some of them there. I'm testing that I can save and retrieve a breed. I'm testing that when I save a cat, it also saves its breed. I'm testing I can get a list of all the breeds. And I'm testing if I save something multiple times, it will overwrite and not keep creating new objects. And of course I have similar tests for saving, retrieving a cat, and getting a list of cats. So to look at that first method, the save and retrieve breed method, it's fairly simple. We just create an expected breed that we want. We put it into our facade. We pull it back out again using the ID that was provided. And we check that what comes out is what we put in. Now to implement this test, I'm subclassing my test base and just writing a setup method. And this is the entire code for this particular memory facade test. So what I'm doing is instantiating a facade for the test to use. And then looking back at the implementation, I'm using the facade here, which is the one provided by the subclass. So I've got a test for that. How do I use it in my view? Well, this is a different view. This is one for getting the list of cats. But all I'm doing is instantiating the facade and then calling my getAllCats method, which I've previously tested, and rendering that template using the standard Django renderer. So this is good, but looking back in the pros and cons, it's volatile. It's lost on every Django restart. That means if you're running the debug server, every time you save a file, you're going to lose everything. So that's not quite, not that good if you want to have a consistent view that you come into and you see a list of things that you expect to be there. So I'll improve it slightly with a take 1.5, which is still using an in-memory database, but I'll populate it with some test data. And that's simple. I just subclass my memory facade, and in the clear method, I'm inserting a bunch of breeds and cats. And then when I look at my view, I get my pre-populated list of cats there. So how do I use this new data facade in my view? Well, the view code doesn't change. I'm just changing in the background, I'm changing what facade is getting loaded. So again, this is quick to write, simple, in memory fast, and also it's preseeded with test data, so every time we go in, we can see the data that's in there that it's instantiated with. But again, volatile. Every time I save a file, I'm going to lose everything. So we should try to take care of this. So the next implementation, I'm just going to be storing this on disk instead of in memory. So it's slightly different, but it has the same interface. Now if I want to get an object, I call this load object method and pass it the generated object path. If I want to put an object into it, again it sets the object ID and then writes it to some generated object path. And if I want to get all the breeds, so get a list, I'm listing the directory containing whatever my objects are and just mapping that to my getBreed method, so it gets called for every item in that directory. And the store object and load object are very simple. They're just using pickle to either dump to disk or load from the disk, respectively. Now to use this in my view, again, view code hasn't changed at all. So how do we change out the facade that we're using? Well, in my case, I've decided just to do it really simply. Just in the settings pie, I'm importing all my facades and commenting out the ones that I'm not using. But it's up to you how you want to do this. You could use an environment variable to switch so that perhaps in your CI smoke test, you're just using a preseted memory facade to get a clear, consistent look of some data. Maybe as you move through your delivery pipeline, you change to using a real data store. So this on-disk storage, again, was quick to write, simple, and it's persistent between Django restarts. The cons are that it's on the disk, so it's slower. And how do I test this? Well, just to remind you of what my memory facade test looked like. This is the disk facade test. So the only thing that's changed is I'm now loading to a disk facade instead of a memory facade. All the test methods are still the same as they were before. So this is the power of developing in this way. You can have a consistent interface, change everything, and you don't have to change your tests. So I've looked at a view which is already using the facade, and we can see as we change the facade backends out, we don't have to change the view. But how do you convert from the old way into this style? So this is the new single breed view. And I'll go through and just compare it to the old way. So the old way, when we're getting the breed out, we're just using the Django ORM. In the new way, we create a facade and call our facade's getBreed method. In the old way, we were using a model form, so we can pass our breed instance straight into the model form. And in the new way, we have to create some, it's not a model form anymore, it's a standard Django form. So we're creating some initial data which we're then sending through. In the old way, to save data, we just check if the form is valid and then save it. The new way is a little bit longer. We need to instantiate the breed object from the form data and then put it into the facade. So that's developing and testing the sort of back end. What about testing this boundary here? Well, we've got a standardized interface, so we can mock it. And we can test that our view calls all the methods that we expect on our data facade. So we're just mocking the facades. In the setup method, I'm just patching my facade loader, patching Django's render method, and patching the breed, the form, Django form, so that I have mocks for all of those. And then to test it, this is just one of the tests I have. If I'm testing that I'm getting a list of breeds, I have an expected context, which I'm sending through to the render method, and I'm just asserting that the render method is being called with that context. So this context should be built with a list of objects that come out of my facade from the getAllBreeds method, and I assert that it goes through to my render function. Testing getting a single breed is kind of similar. We again have an expected initial value which is going through to our form. We have an expected context which is going through to render, and then I'm just asserting that I'm calling the form with the right data and calling render with the right context which contains that form. So the expected initial values that I have, the name should come out of the data facade's getBreed return value, and the context, the form, should be whatever was rendered with that breed form method. testing getting a new breed, so this is one that doesn't exist yet. It's fairly similar. I've just changed the expected initial value that I should be getting, so that the name should now be blank if we don't actually have a breed. But again, the context is just containing that form. So what about testing here? This is sort of the layer between what you're presenting. This is your HTML that you're presenting to the browser. So we can test this in the standard way, like with Selenium. But now if you want to, you can switch out the backend facades to get known data to render. So as I mentioned, maybe in your CI system, you want a consistent view in one of your dev environments so that you know that your rendering is all working properly. And if you wanted to, you can switch out your template generator, i.e. Django, and you already have tests in place at both ends to help you know that you've done that correctly. So what if we want to write another backend? Well, first we need to ask, does the on-disk storage actually fulfill all our needs? And it might do. So why not put that into production if it works? On the other hand, it might not, in which case we'd have to code another data source. Now this is simple because we already have an interface that we have to code to, and we've got tests for it. So all we need to do now is just go through and fill in all those blanks. So let's say we wanted to store in a SQL database. We change our getSingleBreed method to do select star from breed where whatever. Let's say we wanted to store in a Mongo database. We change our view to do collections.breeds.find whatever. Let's say we wanted to use Neo4j, some crazy Neo4j syntax. What about when CheeseburgerDB comes out? Maybe we just write icon has breed. So let's ask why we might actually need a database. Well, one reason might be searching, because with our memory and on-disk facades, we don't really have an easy way just to search for objects. So when we want to write a search method, add a search method to our real facade, i.e. the database facade, we'll just we'll write a new method called breed name search and implement it with our select star from breed where name like whatever. We need to also add that same interface to all our mock facades so that they all work in the same way. But you don't have to do it properly. For example, you could just pass in the name and say if the name is whatever we're looking for, return some set data, otherwise return an empty list. You could even, if you wanted to, write a method that would go through your dictionary or look through all your files to find data you're looking for. It's up to you as to what you actually want to provide for whatever level of testing that you're at. So another advantage of doing it like this is that it's easy to create libraries from your code because everything's already separate. So let's say that another team in our organization wants to access our data. Well, yeah, your library's already separate, so it's trivial to provide that without giving your whole presentation layer. What if another organization wants to access our data? Well, now it's trivial to instead build a REST API using a lightweight framework on top of your library. Just on the subject of deployment, you should treat your library as a separate package. So it'll have its own version, and you can refer to that version in your main application's requirements.txt, and then just host your library on DevPy or whatever you use. So there are some downsides to the style of development. A lot of Django things won't work. So because you're not using the standard Django models, your admin interface won't work, model forms don't work, and you have to, well, your migrations don't work. It may be possible to code an intermediary layer that will take data out of a facade and translate it to a Django model, in which case that would solve the first three things there. But I haven't tried to do that, but it could be possible. You have to manage everything yourself. So as I mentioned, you've got to do all your own database migrations, but there are third-party libraries that already do that. And you have to manage database connection sessions in your web layer yourself. And there's, of course, some overhead to it. As we saw, the view methods are a little bit longer. You're writing mock facades for stuff. And of course, it makes you test, which is good, but takes time. And so for small projects, it might not be worth it. So just to conclude, this talk was somewhat inspired by Uncle Bob's clean architecture and design talks. There's heaps of them on YouTube, and he goes into the theory behind this in a lot more detail, so really good to watch. If for some reason you wanted to make your own cat database, you can fork that on GitHub, see the full code there. And what can I say, but try it, you might like it. Thanks.
All right, do we have any questions?
Hi. Django has model managers for models. So you've got a model data thing dot object dot call to the gets you a model manager method. That could be a nice place to. Those could be nice things to chuck behind the data facade.
Yeah.
So
Yeah, so you could use your data facade as a front to the Django ORM if you wanted, yeah.
And then you get everything for free that Django gives you.
Yeah.
And it's tidy. It's hidden away.
Yeah, good idea.
Sorry, I lost the hand over here. Who was it? No? Yeah.
So, I don't know if this is on. Okay. I don't know if maybe you just touched on that. I'm not quite sure, but I tried something like this in the past. So I had my, it wasn't a class, it was a module, but anyway, so it was like my database library, my access to everything, because I thought one day I might have to switch out the backend, who knows, right?
Yeah.
So, and then I tried to abstract it out, and I found myself transcribing whatever it was in the query set that Django gives me back in the ORM to some dictionary, and that got really tedious, and then you end up just passing the query set out. And then you realize that query sets allow you to build more queries on there. And if I don't want my other parts, my view code or whatnot, to be too tied down to the ORM, to the Django ORM, I can't do this nice thing that the query set allows me to do and build more queries there. So I need to go back to my database access little layer library. And it becomes this huge pile of random queries, which I just need now some sort of abstracted away into this library. And it gets from all these different parts of my application. It has these random queries, which are just basically encoded in there.
Mm-hmm.
And you have like a little function call that does that query for you. And you just end up having this knowledge leak from everywhere into this one place. So what is the strategy around that?
Write your facades better. Yeah, try to have a consistent interface. Decide what the data that you're actually getting out is. Maybe your facade needs to do some transformations as well. So it sounds like you have a bunch of different queries that are all kind of slightly different, and they should be their own methods. It's hard to say. Yeah, it's more about being able to get the data provided to you in a useful way. And the point of this was about not coupling yourself to anything, so having control. So I guess, yeah, if you're putting your Django ORM into stuff, you're not really decoupling yourself from that. You're still tied to it in some way. And as I said, this is not going to work in every situation, but it's just useful to have in your toolbox and have that way of thinking as well.
Alrighty, thank you very much. And thank you to Ben.
Cheers.